Let's build a machine learning model to predict the outcome of a very special game happening tomorrow. So tomorrow there's an NFL game between the Philadelphia Eagles and the Dallas Cowboys, and everyone has their opinion of who's going to win. But instead of arguing about feelings, today we're building a supervised learning classification model on this real Kaggle dataset to predict the outcome of the game. More specifically, today we're training a logistic regression classifier. In plain English, that just means I give the model a bunch of past games where the outcome is known and it learns to predict a probability that the home team will win. So instead of telling us something like the Cowboys win for sure, it'll say there's a 63% chance that the Cowboys will win based on patterns it has seen before. We always begin by importing all of the needed libraries. Pandas for data, NumPy for math, and default dict is your little notepad per team where you can keep streaks and check scores without constantly checking whether the page exists. Then we bring in lots of members from our scikit-learn cast, which is our machine learning toolbox. One-hot encoder will turn the team names into numbers so that the model can understand them. Each import serves a various function, and these will help us do everything from cleaning the data to training it to evaluating it. Now we actually need to get our data, so we import the CSV file from Kaggle into our official data frame. And now we're making a creative decision about the world our model will live in. Basically, we're deciding that only the modern era of football matters for this model. Rules and styles have changed a lot across decades, so games from the 60s would only confuse things. And that's why we're building a filter that only keeps games that happened after 2002. Now we're dropping all the games that don't have scores yet, and converting the schedule data from a string to a real date-time object. Now it's time to actually define the question our model is going to answer. Each game we want to know whether the home team wins, so we compare the amount of points the home team scored and the amount of points the away team scored. And the comparison yields a series of true or false values. The result is a new column called home win. And this is the label that your model is trying to predict. Every other feature you build is there to help explain or anticipate this one number per game. Now it's time to get into the secret sauce of the whole project. Static features like the season and the week are useful, but we also want to analyze the momentum. Is the team we're looking at right now hot or ice cold? The function we're defining now is called add team form features, and it'll go through the games in time order and keep a running memory of each one. Here we're building something called form features, which describe how the team has been doing lately, avoiding any data leakage. Inside this function, the games are sorted by their schedules so that you always go forward in time. Then a default dictionary called state is created, where each team name maps to a small dictionary containing three things: a streak value that calculates current wins or losses in a row, a recent for list that stores all the points the team has scored in recent games, and a recent against list, which holds all the points the home team has allowed to go to another team in recent games. But before updating anything, it looks up the current states for the home team and the away team, and uses those states to build features for this particular game. It appends the current streaks to lists that will later become home streak and away streak, and it computes the averages of lists like recent for and recent against to create lots of new lists. The key point here is that the features are using the previous games only because the state has not been yet updated within the current game's result. Only after those features are recorded does the model update the state for both teams with the outcome of this game. It appends the home team's points scored in this game and how many points it allowed. It then appends the streak variable. If the home team won, then it increases the streak by 1, but if it lost, then it decreases it. After doing basically the same thing for the away team, the function trims both recent for and recent against, so it only keeps the last 5 window entries. Conceptually, you now have for each game a snapshot of each team's recent form. Now that those form features are added back into the main data frame, the code chooses which features will be used for modeling. It keeps lots of different features, some including the season, the week, the home and away streaks, and pairs those with the target column, home win. And lastly, it drops any rows with missing data. The script then does a time-based train test split. Instead of shuffling everything randomly, it says seasons up to and including 2018 will be the training data, and everything after that will be the testing data. This means that the model is trained on only old cases and evaluated on only new cases, which is much closer to the real use case where you train on the past and predict on the future. Now we build the reprocessing and the model in one pipeline. Essentially, it tells scikit-learn that the names are categorical features and everything else is numeric. The numeric features go through a standard scaler, which just shifts them a little bit so they're all on a comparable scale. And the categorical features go through one hot encoder, which turns each name into a set of columns. Column transformer includes both of these transformers so that the correct transformation is applied to the correct type of feature. And the pipeline ties it all together so that when you call fit on this model, it learns the scaling and the coding on the training data and then fits a logistic regression on all the transformed features. Now we're training the model and it's finally time to make predictions. The script evaluates it on the test set to get for each game the probability that the home team wins. And finally, transform those probabilities into a hard win or hard loss using the default cutoff of 0.5. If the probability is higher than 0.5, then the home team has won, and vice versa. And now we need to check how well the model actually did, so we compute the accuracy, ROC, AUC, Brier score, and a classification report. And here are all of the evaluation metrics for this model. And finally, we're applying it to this weekend's game. The code filters the data frame to find games where the Philadelphia Eagles were the home team and the Dallas Cowboys were the away team, sorts those games by the date, and picks the most recent one. It takes the feature values for that game, runs them through a trained pipeline, and prints the probability that the Eagles will win at home in that specific matchup. It looks like the model predicted that there's a 78% probability that the Eagles will win this Sunday. So don't forget to save this video so you can come back to it after the game this Sunday. Let me know who you're rooting for in the comments and follow for more.